welcome to YouTube Learning. Today we shall start a new chapter in physics, that is energy. Okay, so in your lower classes you have learnt about the concept of energy. So what is energy, children? Energy is the ability to do work, is it not? So energy is the ability or capacity to do work, right? Now we know that to do some work we require some energy, and if you have energy you can do some work. So both are interrelated. Energy and work are interrelated. Why they are interrelated? Because if you have energy, then only you can do the work. And if you want to do some work, then you require some energy. Okay. Now, usually we come across so many types of works. We have mental work and physical work also. Like you are sitting and studying, you are preparing for an exam. Someone is standing on the desk and giving lecture. Is it not? Now I am standing and I am teaching for you. Now, such type of work is not considered as work in physics. Any physical work is considered as work. Now, mental work, if you are sitting and studying, you are using your mind, is it not? So, such type of work is not considered as work in physics. Suppose you will walk from your bedroom to kitchen, then it is called work because there is displacement, right? So, remember, mental work is not considered as work in physics. Only physical work is considered as work. Now we shall discuss about the concept of work done. Now, work is said to be done. Work is said to be done if a force acting on a body causes displacement in it. Causes displacement in it. Okay. So, definition of work done. Work is said to be done if a force acting on a body causes displacement in it. Suppose I have a body here and I apply some force. Then what happens when I apply force? The body moves for a certain distance, means there is displacement for the body. Displacement, either you can denote it by the letter S or D. So in textbook he has denoted by the letter S. So let us consider the displacement as S. Now here what is happening? I am applying force and some displacement is caused. In such cases only work is said to be done. Okay. Now work done is represented by the letter W. So work done is equal to product of force and displacement. Work done is given by the product of force and displacement. So mathematically how I can write work? W is equal to F into S. So this is the formula which you have to remember for work done. Okay. So, how do you define work? Work is said to be done if a force acting on a body causes displacement in the body. And what is the mathematical expression for work? Mathematical expression is W is equal to F into S. Please note down these things. Okay, now let us consider which are the factors which determine the work done. So according to the formula, what we have learned, W is equal to F into S. That is product of force and displacement. Now, factors determining work done. Now, if you consider the formula W is equal to F into S, you can make out which are the factors which affect the work done. So, work done depends on magnitude of force. Magnitude of force. Magnitude of force means the amount of force you are applying on the body. Okay. So, magnitude is nothing but numerical value. How much force you are applying on the body, that will determine the work done. And what is the second factor? As there is a displacement in the formula, so displacement is another factor which affects the work done. So remember, two factors, work done is based on two factors. One is force, that is magnitude of force, and then displacement. Okay. Now again, take the formula W is equal to F into S. Now from this formula you can write down the standard unit for work done. We shall discuss the SI unit, that is standard units for work done. Now if you take a force, what is the standard unit of force? The standard unit of force is Newton. Is it not? For force it is Newton, and for displacement is nothing but the distance measured. Okay, distance covered by the body. Distance, what is the standard unit, children? It is meter. Now, Newton meter. Newton meter is the standard unit of work done. Okay, so you can write Newton meter or symbolically capital N, small letter m. But already in the beginning what I told you, work and energy are same. Is it not? If you want to do work, you require some energy, and if you have energy, then only you can do some work. So, because work and energy both are same, we can give the same units for work done also as we give for energy. Now, for energy, what is the standard unit we use? For energy, we use joule, right? Even for work done also, you can use the same units. So, the standard unit of work done will be either Newton meter or joule. So these are the units of work done. Okay, write down all these things. So once again I will repeat: factors determining work done, that is magnitude of force and then displacement. Now coming to the standard unit, which is the standard unit? It is Newton meter, and because we know that work is nothing but energy, so I am using the same units for work done also, so you can write it as joule. Okay. Next. Again consider the formula W is equal to F into S. Now, here, suppose S is equal to 0. You are applying some force on the body, but there is no displacement caused. For example, pushing a wall. Suppose if I try to push this wall, then what happens? If I try to push the wall, I am applying force on the wall, but whether the wall is displacing, it is undergoing any displacement? No, no displacement is caused. So what is happening here? I am applying some force, but displacement is 0. If displacement is 0, then work done will be equal to 0. So this is one important point you have to remember. Sometimes work done will be 0 even though force is applied on the body. Okay. So which is the first case? If displacement is equal to 0, then work done also will be equal to 0. Right? Next you see. If force applied and displacement right angles to each other. So, what is the second condition? Second case, if force applied and displacement are at right angles to each other. So, then what happens? You see. Suppose you are walking on the ground. You are walking on the ground. Now, when you are walking on the ground, what is happening? You are moving in this direction. This is the displacement. This is the displacement. Okay. Now, whenever you are walking or standing, the force will be acting towards the earth. The force will be acting towards the earth, and that force is called force of gravity. It is called force of gravity. Now, if you observe here, when you are walking, then in which direction the force is acting? The force is acting towards the earth, so I am showing it vertically downwards. And what is the displacement cause? Displacement is in this direction. Now note what is the angle between these two. The angle between these two is 90 degrees, right? Means force and displacement are at right angles to each other. When force and displacement are at right angles to each other, here I have written, if force applied and displacement are at right angles to each other, then work done will be equal to 0. Understood? So, these are the 2 points you have to remember. If W is equal to F into S, if you take this formula, even though if you apply force, the displacement cost is 0, then work done will be equal to 0. Now, when you are walking, then what is happening? You are applying force on the ground, that force is equal to force due to gravity. Force due to gravity, and it is acting towards the center of the earth, and displacement is in this direction. If you observe, force and displacement are at right angles to each other, then also work will be equal to 0. Now why work will be equal to 0 in these two cases? Here displacement is 0, so F into 0 will be equal to 0. Here we are resolving work done into components, vertical component and horizontal component. Of course, it is not there in the scope of your syllabus. When you go to higher classes in 10th standard, you will learn more about the concept of work done. There we will prove how work done will be equal to 0 when you are walking on the ground. Okay. Now for now you have to remember, if S is equal to 0, W is equal to 0. Then if F is, so if F is perpendicular to S, then also work done will be equal to 0. So this is about the concept of work done. Okay. Please note down this. Now we shall solve 1 or 2 problems on work done. Now one more point which you have to remember is, so force acting on the body and displacement cost both should be in the same direction. Then only work is said to be done. Okay. So here, if you observe, force and displacement are not in the same direction, so work done is 0. Here displacement only is 0, so work done is 0. If force and displacement are acting in the same direction, then the work is said to be done. Okay. Now we shall solve 1 or 2 problems. So I have one problem here. I will read out the problem for you. See, a force of 25 newtons causes a displacement of 4 meter in its own direction. What is the magnitude of work done? So let us solve this problem. A force of 25 newtons causes a displacement of 4 meter in its own direction. What is the magnitude of work done? What is the magnitude of work done? So now here some body is there. How much force is applied on the body? F is equal to 25 Newton. Now he is telling that displacement is caused in its own direction. Means this is the direction of force applied. In the same direction displacement also takes place. How much displacement we have here? It is 4 meter. Okay. So solution. Force is equal to 25 Newton. Displacement is equal to 4 meter. Now work done is equal to formula F into S. So W will be equal to 25 Newton into 4 meter. How much it will be? W is equal to 25 4 times will be 100. Right? 100 Joule is the work done. 100 joules will be the work done. Note the solution, children. Okay, next problem we shall solve. Next problem you see. A boy does a work of 800 joules in dragging a sack. In dragging a sack of rice through a distance of 10 meter. What is the magnitude of force applied by the boy? What is the magnitude of force applied by the boy? Now you see, a boy does a work of 800 joules in dragging a sack of rice. Now, how much work is done? Solution. How much work is done, children? 800 joules, right? Now, distance, that is displacement, is equal to 10 meter. You have to calculate the force. Force is equal to question mark. Again take the formula. W is equal to F into S. Now W is how much? 800 joules is equal to F into 10 meter. F is equal to 800 joules by 10 meter. Now 800 joules means you can take it as Newton meter also. You can take it as Newton meter. Now how much will be the force applied? See, force applied will be equal to 80 Newton. So the boy has to apply a force of 80 Newton to drag a sack of rice through a distance of 10 meters. So copy the solution. Always be careful with the units. You should not forget to write the units. Correct units must be written. Now here joules. Joules I told you, work done, either you measure in joules or Newton meter. Here see, joules means Newton meter only. M gets cancelled and you are left with the N. So 800 divided by 10 will be equal to 80 Newton. Okay, copy the solution. Next problem, I will give it for homework. You try that problem. Okay. So last problem, I will give it as homework. Try this homework. A girl applies a force of 15 newtons in pushing a table such that work done by her is 25 joules. Okay, calculate the displacement produced in the paper. Calculate the displacement produced in the paper. So here what you have to calculate, displacement must be calculated, force is given and work done is given. So take the formula, W is equal to F into S. First write the data given, take the formula, substitute, simplify and express your answer with correct units. Okay. So try this out. We shall continue in the next video. Thank you children.